like the video and comment. Hey guys, welcome back to AlgoYogi. We are doing graph series, and our next problem in the list is find closest node to given two nodes. So let's go to LeetCode and give this problem. You are given a directed graph of n nodes numbered from 0 to n minus 1, where each node has at most one outgoing edge. The graph is represented with a given zero-indexed array edges of size n, indicating that there is a directed edge from node ith, so the index, to the node edges ith, basically the element that's at ith position in edges. If there is no outgoing edge from I, then that value would be -1. So you are also given two integers, node 1 and node 2. Return the index of the node that can be reached from both node 1 and node 2, such that the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. If there are multiple answers, return the node with the smallest index, and if no possible answer exists, return -1. Note that edges may contain cycles. The reason I'm laughing is I'm sure you guys must have just found it so hard to understand what the fuck they're trying to say over here. But let's decode this. Let's decode it. And I immediately started laughing because I know, because I didn't fucking get it, like what they were trying to say in the beginning. But of course, you would understand now. So we are given, let's say, n number of nodes. They are numbered from 0 to n minus 1. So in this case, we have taken an example where we are given 4 nodes. So numbers would be 0. Let me just put these indexes here: 0, 1, 2, and 3. By the way, I have copied those those 2 lines where things were getting complicated to comprehend and understanding what the fuck this problem is actually asking us. Now, so we are given the graph has n number of nodes, and we are given edges, and at most there is only one outgoing edge. It's a directed graph, so there is only outgoing edge from one nodes, but there could be multiple in degrees. In degrees means incoming edges. So just like 2 here has 2 incoming edges, but there is only one outgoing edges. So now this represents the outgoing edge to which node? So 0 has an outgoing edge to node 2. All right. So here we are given edges. We can convert that to adjacency list. That's how we have usually been solving our problems, if you remember. And then we are given 2 nodes, node 1 and node 2, node 1 and node 2. And now let's get into this. Now we need to return the index. What are the indexes? These are the indexes. Return the index of the node that can be reached from both node 1 and node 2. So these are our node 1 and node 2. So node 1 is 0, node 2 is 0. So these 2 nodes, I'm just gonna mention them right here. So node 1, and this is node 2. Okay, such that maximum between the distance from node 1 to that node and from node 2 to that node is minimized. So what they're saying is we have to find out what are all the nodes that we can reach from both of these nodes. So let's say node 1, I'm going to have 2 maps created, 2 maps. So node 1 distance, and then I'm going to have node 2 distance. I'm just going to call it this. Okay, these are the 2 maps I will be creating, and the reason I'm creating these so that I can have all the distances calculated from both the nodes that are reachable from these 2 nodes. So let's say from node 1, what are all the nodes that I can reach? I can go to node 2, I can go to node 3. So I can reach 2, and then I can reach 3. What are the distances from nodes 0 to 2 and 3? Well, the distances from 0 to 2 is 1, and from 0 to 3 is 2, right? Basically, I'm just counting the number of edges that's taking me, to these nodes. Well, how about node 2? Well, node 2 can also, which is node 2 is 1, that can also go to 2, and then it can also go to 3. So what are the distances from this? This is also 1 and it's 2. Okay, so now I have all the nodes that are reachable from node 1 and node 2, and the distances also calculated. Now what we need to do, we need to find the maximum between the distance from node 1 to that node and from node 2 to that node is minimized. So what is, okay, let's say this is what we need to do. We have to basically look over these values. So let's say in this case 2 is that node that's reachable from both these nodes. Okay, so it's reachable from node 1 and node 2. So 2 is common, right? 2 is common because there might be some nodes that are not reachable by both node 1 and node 2, but we need to only look for the nodes that are reachable by both the nodes. So here 2 is reachable. So what is the maximum distance right now in both of these? That is 1. So maximum distance is 1, and we have to minimize it. So right now we have to minimize it. So right now it's 1. It's 1. Okay, so we have to minimize it. What about the next node? 3 is also reachable. Well, that distance is 2. So between 1 and 2, what is the minimum? So here the maximum is 2 because both values are same. But what is the minimum between 1 and 2? That is 1. That is what we return. The 1 will be the answer for this problem. That is exactly what we will be doing. We have decoded what they've asked. So they're simply, I would say, like, I'm sure some of you or most of you just understood the assignment in the first go, but I didn't. So that is why, like, I wrote it down right here and then just trying to get through what they're actually asking us to do. And then once we have these two maps ready, we can go over all these basically indexes from 0 to n minus 1, and then see what are those nodes that are present in both of these, except did they say like these two nodes could be actually a part of the solution? So maybe, yeah, I think we will go through all of these nodes, and then we will be just finding those common, those nodes that are present in both the maps, and then taking their answers and then getting the maximum out of these, and then having some answer, basically initially infinity, and then keep minimizing, keep just updating it by going through all these maps. So I think the problem is quite really simple. First thing is just creating these two maps, then populating them. Basically, we can populate both of these by actually running BFS on both of these nodes, so node 1 and node 2. And then once you run this BFS, during the BFS, we can actually take care of all the nodes that are reachable and keep adding it to your maps, and then also have the distance calculated level by level. Okay, so I guess you know what I'm talking about when calculating the distance while running the BFS. So we can make use of the BFS, although BFS DFS will not make a difference in this problem, because we have been told that there is only one outgoing edge from each, at most one outgoing edge from each node. So it's like DFS and BFS, they will both take equal number of execution, that. So okay, let's write down the code. So let's get the number of nodes, that will be length of the edges. Then we will be writing the function BFS right here, but let's just come back to it. It will take the source node, or you can call it source node, could be said U and V. So but before that, we will be creating two you can say dictionary or maps. So node 1 dist map and node 2 dist map. So I'll just write it like this. And then these two will be basically coming from our BFS. So BFS will take node 1 as first source node, and second will take as second source node. Okay. All right. So now is the time when we should implement. Okay, so let's implement BFS, and I'm just gonna call it back SRC. So now first thing is we need the distance map, and then we also will need a queue. So I'll just call it queue, and we can use DQ, the inbuilt data structure, for our efficient algorithm. And then we can just put in the source node into it in the beginning, and then also in dist we can append the source node's distance as 0, right? Its distance to itself is currently 0. Then we can have our while loop. Of course, it's BFS. Now let's pop out the source element from where we are calculating the distance. So it's going to be q dot pop left, and we can get it from the edges. That's why we don't need to create the this adjacency list. Usually in our problems we have been creating the graph adjacency list and then do the traversal from there. But here edges has only one outgoing. This graph has only, from each node there is at most one outgoing edge, and there might not be actually. So we'll put in the u here, and we'll have to check actually. So if v is not equals to -1 and the v not in our dist set already, okay, so if not in this already, so I'll just put this in another bracket, okay, just to be safe. Now what you can do is, if that's the case, then there will be one outgoing edge which is from u to v. So you want to calculate the distance, and distance would be of this v will be actually the distance of source, which is u. So for v the distance would be, you can call it the distance until u and +1, okay, +1, because you're going from u to v. And that would be it. Finally you can come out and you can return this distance, dist map, and for node 1 and node 2 it should give us this distance map. All right, now we have the distance map, right? We have the distance map. So we will do this one thing, that we're going to traverse both all the nodes and see if those two nodes are present in both the map, and then if what is the maximum value from each, if for one key, and keep changing your answer to the node if there are lesser values. So we are trying to minimize it. So let's say best distance is currently, it's going to be positive infinity. It's like huge. We need to bring it down. So float, that's how you do it in Python. And then also answer is initially going to be -1, right? -1, and then we're going to traverse basically for node in range n, okay, from 0 to. So if this node in my basically node 1 distance map and this node in my second node map, then I have to do one more thing. I have to check I have to get the value. So let's say dist 1, or maybe let's just say min dist would be actually not min, max distance. So max distance, we will minimize it, we will minimize the answer, but we're trying to find the maximum value if they are both present. So give me the max of these two values from node, and then also this is 2, by the way. Oh, I didn't change it to 2. I was like, I copied it, but it's telling me the same value. So this 2, and give it basically the node as the key if this is present in both of it. So now I have the max distance. If this max distance is lesser than best distance, then best distance is going to be max distance. Wow, nice. And one more thing, we have to our answer would be that particular node that's reachable from node 1 and node 2. So it will be node. And then finally we can just return our answer. Okay, that would be it. So let's zoom out. I'm gonna zoom out and let's try to run it. Maybe there might be some typo, but we'll come back to it. Okay, committing typo is bad, but it's not crime, right? Okay, so let's go over it again so that we don't have any typos. Yes, this one has to be 2. Correct. There is a mismatch. Parenthesis, but also, oh my god. Okay, so this is another thing. We are calculating the distance, but like this v has to be added to our q. So we have to append v as well so that it can be, calculate more reachable nodes from it. All right, so I think that would be it. Let's try to run it. Awesome, and submit. Great. All right, so that's the entire code. Now let's write down the time complexity, which would be big of n. That's the total number of nodes, but we are running this BFS. BFS takes n time complexity, and that is because it's visiting all the nodes. But in this case, we are running BFS twice, so you can call it 2 into n, or just n. Yeah, and then for a space, for some reason why this C typed, for space complexity, we can say for space also we can have 2 into n or just n. We have 2 maps, right? Okay, so awesome. Let's mark this problem solved. See you guys later. Like the video.